It said which functions when integrated from negative a to positive a are equal to 0. So we don't have specific numbers, but that's okay. We can use the fact that it's talking about an integral using symmetry. This could be negative 2 and positive 2, could be negative 5, positive 5, we don't know. But what you want to do is consider what these graphs look like. Natural log of x looks like this. I can't even integrate from negative a to positive a because natural log is not defined for negative numbers. You can't find the natural log of negative 2, for example. So this one is not equal to 0 because you can't even evaluate it. It's undefined. Square root of x plus 3. So square root of x looks like this. If you do plus 3, then you've shifted yourself 3 units to the left. So we don't know where that's going to land us, but we can confidently say this is not going to be 0 because the area under the curve here is going to be positive. Okay, so that is also not 0. Cube root of 3. So if you graph a cube root, it looks something like this. And since it's centered at 0, this one does have symmetry. This negative area and this positive area are going to be the same. So this integral from negative a to positive a will be 0 because we're adding the same negative area as the positive area. So this one checks out. X squared plus 3, that is quadratic, so it's 3 units up for a vertical shift. Looks like this. So this area plus this area is just getting, those are both positive areas. Those don't cancel out. So it's not going to be equal to 0, okay? So not that one. Sine of x, the graph looks like this. Okay, starts at the origin. So that's a graph where we're going to say, well, actually, because what if A didn't end right there? What if it looked like this? Let me think for a second. What if this is, oops. Yeah, that's the same no matter what. For sine of x, however you graph it, because we don't know what an A is, it's always going to have symmetry around y equals 0. This side is always going to be the same as this side because there's no shifting going on. So this negative area plus this positive area, they're the same area. So that should be 0. Cosine of x is a different story though, because cosine of x looks something like this depending on where a is, and that's actually at 1. So if you graph cosine of x, it has symmetry, but you're adding positive area to positive area. And then this is going to be negative, and this is going to be negative, but they're not guaranteed. These two areas are not guaranteed to be the same. I think there could be a value for a that would make these two the same, but since it's not true for all values of a, we'll just cross that out. So this one yes, this one no. 1 over x squared. So if you graph that with your calculator, that's squaring both sides. Man, I'm having a brain fart. That should look something like this. Because all the negative values, if you plug in negative 1 squared is positive 2. Oh, sorry, it should be going down though over here. Oh, what is that going to be? So if you plug in negative 1, oh yeah, I had that right. Looks like this. Because if you plug in negative 1 squared is positive 1, and 1 divided by 1 makes positive 1. So the negative values are going to be positive, but we can't even integrate this one because the integral from the left side is undefined. That area never stops increasing. So, but even if you could, this is positive, this is positive. A positive plus a positive is not going to be negative. Okay, next one, x to the third. That graph looks like this. This one does have symmetry on both sides. So this negative area between the curve and the x-axis and this area are going to be the same. So this next one, that's absolute value looks like this. So if you do minus 2, you've shifted it down 2 units. So this one, again, you could probably find one particular a that would make this be true, but look, this area and this area added together are not guaranteed to be this area and this area, so that's not going to be the same. And 1 over x, same rationale as up here. If you graph it, you've got negative area and positive area, and it looks like they're going to balance out, but the integral from negative a to positive a is undefined because of the vertical asymptote we have here. You can't find the area under the curve.